Okay, another problem of the same type. This time the velocity is 20 meters per second at an angle of 150 degrees, which goes beyond the y-axis, which is at 90 degrees, and on around into the second quadrant, giving us a velocity in this direction. In order to find the x and y components, we just do the same identical thing. The y velocity will be the magnitude of the vector times the sine of the angle, which comes out plus 10 meters per second. And that makes a certain amount of sense. This magnitude is half of this magnitude if this angle is 150 degrees. And if this is in this direction, this will be in the positive y direction. The x component is 20 meters per second times the cosine of 150 degrees. The cosine of 150 degrees is about negative 0.87, which means that this will be negative 0.87 times the magnitude of this. Notice that since we're at 150 degrees, the cosine just comes out negative, and that's going to give us a negative x velocity, which is what we need. The x-axis goes this way, positive x-axis goes this way, the vector goes this way, it has to be negative. As long as we measure the angles from the positive x-axis in the counterclockwise direction, the sign will always give us the correct y component. It'll be positive or negative depending on the quadrant, but it will always give us the right answer, always give us the right resultant, as will the cosine. Okay? Now, if we go into the third quadrant, we note that the x and y velocities both should be negative. Okay, if an object is moving this way, then if we're going to track it along this direction, we have to move in the negative x direction. If we track it vertically, we've got to move in the negative y direction. Using the same formulas, the x velocity will be the magnitude, the 5 meters per second, times the cosine of the angle, the cosine of 233 degrees in this case, which is 5 meters per second times negative 0.6, or negative 3 meters per second. The y component will be 5 meters per second times the sine of 233 degrees, which is 5 meters per second times negative 0.8, or negative 4 meters per second.